Hi everybody, we are going to discuss physical vapor deposition. And the vapors then condense onto a substrate, forming a thin film. So this is the actually uh, vapors formation process, and then vapors are converted into the uh, thin films. Second method is sputtering, and sputtering involves the removal of atoms from a solid target material through the bombardment of energetic ions. So in sputtering process, basically energetic ions strike with the target material, and during this collision, the atoms from the target material are dislodged. Then these atoms are then deposited onto a substrate, forming a thin film. Sputtering can be achieved using techniques such as DC sputtering, RF sputtering, or magnetron sputtering. Also, the vacuum chamber is a necessary component of the PVD process, and PVD processes are typically carried out in a vacuum chamber to prevent contamination and facilitate the movement of vaporized material. So, vacuum is important to stop the contamination from impurities, and as well as a vacuum is better for the movement of vaporized atoms. The vacuum environment allows for better control over the deposition process and ensures high quality thin film. Here is the layout of the chamber used for physical vapor deposition process, and from left side of this chamber you can see there is the opening for the entry of sputtering gases, and these sputtering gases come inside the chamber. These gases are heated, and as a result, these gases are converted into the ions. These ions then are forced to strike on the surface of the uh, target, that is called the sputtering target. And sputtering target, when is collided with these ions, the atoms are removed from the surface of the sputtering target, and these atoms are dislodged from the surface, and these atoms move towards the substrate. And on the surface of the substrate, these atoms are deposited and result into the formation of a thin film or a coating. And on the right side of this chamber, you can see that if some volatile gases are there, sputtering gas, unused gas that goes out of these types of physical vapor deposition techniques. Some common PVD techniques include thermal evaporation, electron beam evaporation, sputter deposition, for example, DC sputtering, RF sputtering, and magnetron sputtering. Different sputtering sources could be used. Also, arc vapor deposition and laser ablation. These are the different techniques which are used in the PVD process. Coating materials. PVD can be used to deposit a wide variety of materials, for example, metals such as aluminum, gold, and titanium, oxides such as silicon dioxide and titanium dioxide, nitrides, for example, titanium nitride and chromium nitride, and carbides, such as titanium carbide and silicon. Advantages of physical vapor deposition. Physical vapor deposition offers several advantages. For example, thin films could be developed on various substrates, including metals, semiconductors, glass, and plastics. So, a variety of substrates could be used in the method of physical vapor deposition. The choice of substrate depends on the specific application requirements. Then the applications of the physical vapor deposition technique. Physical vapor deposition technique is used for a wide range of applications, including coating of cutting tools, decorative coatings, optical coatings, and high purity coatings. Also, excellent adhesion, precise control over thin film thickness and composition, and the ability to deposit thin films on complex geometries. So there are the wide applications of physical vapor deposition technique, including that this technique could be used for the coating of cutting materials, coating of decorative materials, as well as optical coatings, and also this technique could be used effectively for the development of thin films on complex geometries. I hope this video is informative you. Please share this video with your friends and colleagues. Subscribe the channel, and I hope in comment section you will give your valuable comments as well. Thank you.